So in this video, I want to talk about this higher order questioning guide document and also a little bit about the Rigor Reference Framework. So one of the activities that I like to do in class is to have students actually come up with questions for each other, like they're coming up with a test, and then have students exchange each other's questions, right? Answer each other's questions, and then switch back and have the original student grade the questions as if they're grading the test and give feedback to the student. So it's kind of like I like putting students in that kind of teaching role. Now, when I do this, I ask the students to create questions using this higher order questioning guide. It actually lists keywords or activities associated with each depth of knowledge level, right? So you start with something like knowledge, then comprehension, application, analysis, evaluation, and synthesis, right? Now, knowledge is basically just knowing facts about things, being able to describe, being able to tell me what it is, remember it, memorizing it. And good classrooms are not going to be focused only on that information. In fact, nowadays, you have knowledge available at your fingertips. All you have to do is ask your phone and it will get it done for you. Comprehension, on the other hand, is, by the way, that means that computers are good at knowledge, maybe even better than we are, because they can know everything at the fingertip of the internet, right? So we are limited in what we can know. So computers already have us beat on that for sure. But it also, computers have made it obsolete to kind of know so many facts. Now, it can still be useful because it can help give you ammunition to understand, which is the next level. Comprehension has to do with being able to explain, interpret, outline, translate knowledge into different words, which means that you absorbed a little bit of that knowledge. But computers can comprehend too. You can tell computers something, they can understand what you said and search for you. So there's some level of comprehension in there. But I really want to push students to go deeper than those first two levels. So normally when I do this assignment, I tell the students they can only have one out of the 5 to 10 questions they're creating to be out of the knowledge or comprehension level. All others must be from the other levels. And they must use at least one question from every level. So now application has to do with actually solving problems, using the information on something real, demonstrating, develop something, teaching it to someone else, construct something, compute something. And here you have some simple question frames that you could use to create questions for somebody else to force them to apply the knowledge, right? So for example, if I'm doing a topic about motion with constant velocity, right? I could actually ask a knowledge question that just asks someone to define what is velocity. So that would be a knowledge question. A comprehension question would actually be more, can you summarize the steps to figure out the velocity of an object, right? Application would be more if I actually gave you certain numbers and you had to solve a problem where you had to figure out velocity. So you see the difference, right? You're getting more and more complicated as you go down this. Analysis is even more deep, and there's a lot of question frames here that can be used. That's my favorite one because that's where I would like my students to be starting, really. So for example, an example of analysis would be to create a concept map, to provide evidence for something, comparing, contrasting, giving other possible reasons for why something has happened, giving an example of something. So in this example that we're trying to do with velocity, you could just basically have somebody analyze different data to determine which objects have larger velocity, or actually have a person compare and contrast two objects which are moving with constant velocity, or distinguish between velocity and speed, and so forth. So analysis is much more interesting than any of the other previous levels. Evaluation is one that a lot of students will then struggle with. It's one, some people think it's the deepest level you can get to. Other people think the synthesis, but whether one or the other is the deeper of the levels, it can be challenging for some students to judge based on evidence what's better and what's worse, to debate, to convince someone using evidence, to discriminate a quality of something, to say which one is better than the other, to challenge something, to defend something with evidence. Definitely what a science is all about. So, for example, you could give a bunch of data and ask a person what evidence from this data supports the fact that one object is faster than the other. So that would be an evaluation question. Or can you defend your position about whether it makes a difference for the car to move faster or slower when it's raining? You see, so that's kind of like, actually, that was more of a mixture of evaluation and application, which we'll talk about in a little second when we talk about the rigor reference framework. Synthesis, it has to do with creation, coming up with something new, inventing, composing, formulating something, coming up with your own problems, right? Collaborating with others, substituting one problem for the other. So designing an experiment to determine the velocity of an object would be a synthesis example, right? So then this is why a worksheet that you can use to find activities at each depth of knowledge. And like I said in other videos, I give students more points for things that are done at higher critical thinking levels, especially synthesis and evaluation, but at least application and analysis. And you can also create tests for each other using these simple prompt questions which are in the document, right? And don't forget, I also give bonuses out for use of technology, for collaboration, and for real life application, which brings us to our next topic, which is this idea of the Rigor Reference Framework. Rigor Reference Framework is this idea that in one axis you have the thinking axis, which is what we've just been describing throughout this video. And that goes from the acquisition of knowledge at the earlier knowledge and comprehension levels that I described, all the way to the assimilation of knowledge when you're doing synthesis and evaluation, and you're actually using the knowledge at a deeper level. But there's another axis of this two-dimensional axis, right, of explaining ways of learning and the levels at which you're working. The thinking has a lot to do with the rigor. The other axis has more to do with the relevance. It's the application axis. You go from acquisition of knowledge to actually applying that knowledge. So at first you can just gather the knowledge, then you can start applying that knowledge within your discipline. So just solve a physics problem in a physics class alone. Then you can apply it across disciplines. Maybe solve a physics problem where you also put some social studies in there and come up with say you're doing a problem with velocity and you examine traffic issues associated with velocity and the different rules that can be implemented to change maybe speed limits or change the way the roads are built so that cars can move safer or at a higher velocity or whatever. That's an example of applying the topic across disciplines. And actually, I came close there for the next step, which would be using this in a predictable real-world scenario, right? So something that someone would know or have seen and kind of has an idea of what would be necessary and how it would operate like. Finally, the deepest application level that you can possibly get to is when you're trying to do so at an unpredictable real-world situation, something that you have never seen before. If you're doing things at the knowledge and comprehension level and staying only in a discipline or maybe just slightly across disciplines, all you're really working on is this acquire quadrant. And it's kind of nice and important to start there, but ultimately you want to push yourself to the other things, especially towards the adaptation. As you become more across disciplines and applying it in unpredictable scenarios, you're moving into the applying quadrant. Or if you move into deeper levels of knowledge, you go into the assimilation quadrant, even if you're staying within your own discipline. But if you start doing synthesis and evaluation across unpredictable situations, that's when you're getting to the point that you're adapting the knowledge you have gained to new circumstances. And that is where you want to push every student to be working at. The more activities that you work on, which are in this scenario, things which are doing synthesis and evaluation, which you can go back over here to these things to see what kind of activities are like that, and things which are being applied to real world scenarios, especially if they're really weird scenarios we've never heard about before, where we don't really know what's going to happen, unpredictable ones. That's when you're really doing the good stuff. Another way to represent this is to look at a depth of knowledge chart. And this kind of helps you see different key terms which are associated with these different levels of thinking. So I hope this helps you understand that um, it's important to push yourself to work with the content at a multiple levels of learning, so especially the higher ones, so you can be prepared to do things that computers struggle a little bit more with. I mentioned a little bit about the fact that computers can do knowledge and comprehension, but computers can solve problems too, which is application, and can definitely analyze data for you. They can even evaluate data and decide what's more important. For example, when you ask a question to a computer, you can use algorithms to decide what is the most likely answer that you're looking for. That's how Google decides to do search, so that it knows what search items are more relevant to you. And computers are even doing synthesis nowadays. They can compose music, they can write poetry. That means that the jobs of the future are limited to the extent that computers can replace it. There's a really cool video that if you want to watch and learn a little bit more about this, it's called Humans Need Not Apply. It's by CGP Grey, one of my favorite YouTube channels. It kind of talks about this issue that computers are revolutionizing the way that the job market of the future is going to be, and doing the same kinds of things to the job market that the Industrial Revolution did to manual labor. That means that nothing is safe. Doctors, lawyers, all the jobs that you think are going to be in high demand forever are going to be, a lot of it at least, is going to be replaced by computers. I'm not saying humans are going to be completely replaced, but I'm saying you're going to need less people to do the work. So you definitely need to be at the forefront of using deeper critical thinking levels to be more marketable in a world where we need to compete with computers. And you have a cell phone to do a lot of the work for you, don't you? So you already know that you have carrying around a portable computer, kind of like a crush for your brain, expanding the possibilities of communication. Even perhaps doing something similar to telepathic communication. We can communicate across the surface of the earth with somebody who's on the other side. That is an amazing piece of technology that our biology put together with our brains. But now it's also going to mean that you have to work that much harder to guarantee your job in the future. So as a 21st century student, push yourself to think at deeper critical levels. And if you do the higher order critical thinking activity, definitely create more questions at a higher level. And then when you're doing picking activities to doing class from the assignment guide, try to pick activities which are listed here at deeper levels of thinking. I hope you found this helpful.